here's the good news, guys. I have the person I go to with all of my math questions, because you always need somebody just slightly smarter than you. And yes, there is somebody smarter than me, and his name is Jonathan Lamb. Dun, dun, dun! Our superhero of the house. He just came home, and I asked him this question, and of course he had the answer for me right away, because he can see the answer really well. So here was the problem we had. So the question was, a temperature increase of 100 degrees on the Celsius scale is an increase of how many on the Fahrenheit scale? Okay, so I'm going to write this out for you on the board because it actually now makes sense again. So let's look at the Celsius numbers again, okay? So we've got 32 degrees that water freezes, right? And then we've got 212. I'm sorry, this is not the Celsius scale, this is the Fahrenheit scale.
Fahrenheit scale.
So 32 degrees that it freezes at, 212 that it boils at, yes? But and that's the Fahrenheit scale. On the Celsius scale, it freezes at what, Josh? What is it, Josh? What does it freeze at? Oh, you said 0? Yes, very good, 0 degrees. And what does it boil at, Josh? Go ahead, say it.
100.
100 degrees, very good. So the difference from here to here is 100, but the difference from here to here is not 100. What is the difference from here to here? 212 minus 32 would be 180. 180. Okay, so when we're talking about the difference in these two, we can see that there is a difference of 180 between the freezing and the boiling point of water. So the question was, if the temperature increases of 100 degrees on the Celsius scale, how many degrees does it increase on the Fahrenheit scale? And what does it increase by?
180.
180. There's our answer. So the next question that we got stuck on was, a temperature increases of 10 degrees on the Celsius scale is equivalent to how many degrees on the Fahrenheit scale? So if it's 100 to 180, then 10 to what? Look at, all I need to do is move my decimal point over. Decimal point over, and I get, Josh?
18.
18. So there's how I got that 18 answer. So 10 degrees change, 18 degrees change. Now this is really easy to understand now probably if you're using a denomination of 10 or 100 or 1,000 or something with a 0 at the end, right? But what if we had some other number? There is another formula, I alluded to it, and guess who knows what it is? The engineer. So I'm going to hand him the pen, and he's going to tell us about that one. Remember that? You were just telling me about it? The 9/5.
So conversion between the Fahrenheit
Yes.
and Celsius.
The conversion between Fahrenheit and Celsius. And what was there? We were talking about it was something like 9/5 or 5/9 plus 32 minus 32. So which is which? Do you remember which one is which?
So the temperature in the Celsius scale, that will be, I think it's 32 plus 1.8 times temperature Fahrenheit.
Okay. So, but 1.8 could also look like 9/5.
That's 9/5.
Look at the 1.8, you guys. 1.8, 18, 180. Do you see the same ratio sitting there that we were just looking at?
That's
between
right.
the change between?
So that was because we just look at for every 180 degree Fahrenheit, it equals to 100 degree
Celsius. Does that make sense? So let's look at a real world problem. Let's say that I look at my temperature outside in my American, app, and it says right now outside it's 68 degrees. How do I find out the temperature in Celsius from that? So I'm going to plug in my 60 degrees right where that F is. And now all I need to do is to do the math. So 68 times 1.8 plus 32. Yes? 68 times 1.8. 8 times 8 is 64. Carry my 6. 8 times 6 is 48. Plus 6 is... Brain just stopped working. 54. Carry the 0. And then 68. 4, 12, 11, 12. Bring back my decimal point. What did I do wrong? What did I do wrong? Something's not right here. Plus 32.
So 122.4, that's right.
So I'm 154 degrees Celsius.
Should be.
So right now it's 154 degrees Celsius outside?
No, you're doing it backwards. So it should be.
I'm trying to find the Celsius. I know what the Fahrenheit is.
Oh, this should be Fahrenheit.
Ah! Fahrenheit.
And that's Celsius.
Celsius. Okay. So.
So I think you should re-record it.
No, that's okay. I don't need to re-record it. Because you know what? Sometimes when you're doing math, you make a mistake. Not a big deal. Now we know what it is. Let's say we know what the Celsius is outside. Okay, I'm going to erase that too. Okay, let's say we know what the Celsius is outside. Let's say that outside right now, the Celsius is 27 degrees.
That's pretty warm.
Okay, let's just say it's 27 degrees outside.
Perfect.
Okay. So, I'm going to do this again. So, 27 times 1.8, 6, 5, 16, 21, 0, 2, 7, 6, 8, 4, plus the 32, 8, 11.
You need to carry the decimal.
51.8.
No.
48.6.
Plus 32.
Oh, I'm sorry, you're right. Plus 32 over here now. And I get 80 degrees outside.
80.6 Fahrenheit. So it's a warm day.
It's a warm day. So that would be 27 degrees would be a warm day. Ta-da! And here it is. Now what if you had... Dun, dun, dun. Celsius, right? What if you were trying to find it the other way? What do you do then? Oh my gosh. I want to figure out what the Celsius is when I have the Fahrenheit.
You want me to do that? No. Okay.
Yes, go ahead, please do it.
Okay, so when you do the conversion, basically you add, you'll subtract 32 from both sides, so this Fahrenheit minus 32 equals to 32 plus 1.8 minus 32, so you cancel this, and so now you only have 1.8 Celsius, and so if you divide both sides with 1.8,
Divided by 1.8.
then you basically cancel this
Yeah.
2, and you're left with, I can just put it here, just the Celsius temperature. It will be equals to the Fahrenheit temperature minus 32 first, and
Dividing it
by
by 1.8.
1.8. Or, alternatively, you can say is temperature Fahrenheit minus 32, and 1.8 is the same as 9 divided by 5, so you can say 9/5.
There you go. All right, guys, there was your answer. Have a great night. Bye.